Welcome everybody to keep flowing in. Drop a little note where you're calling in from. And yeah, this is a video or a meeting format, so just turn off your video for now, and then we get into the networking session after the panel. We'll get started here in a couple of minutes. We'll let people kind of roll in until 10:03, so about 2 minutes. And yeah, drop in, like I said, where you're calling in from. I'm down in South Bay. I also have Palo Alto. See San Francisco, also San Francisco. Hey, Justine. We have Anto has joined us as well, and we'll get to introducing our panelists here in just a couple of minutes.
Adam, are we panelists supposed to leave our video on? Because I just turned
Yeah,
mine off.
Don, leave your video on. Yeah, and then I'll everybody else turn their videos off.
Yeah, all eyes on me.
All right, so we'll get started here. Folks will continue to roll in, I'm sure, over the next couple of minutes and throughout the call. Welcome to Green Innovation Hub's panel on the reducing or on the lack of knowledge in. Oops, excuse me, my dog is barking. Been good all morning, and then as soon as the panel starts, we'll start barking. On the electric grid risk, we're going to start by introducing everybody on the panel. Our panelists come from utilities, technology companies, academia. So I'll let you all go ahead and introduce yourself while I go and tell my dogs to stop barking.
Should I go first?
Yep, go ahead.
Okay, so my name is Unia Compostela. I have a background in transportation engineering and building energy efficiency. Worked at Uber, 2050 Partners, and Nissan. And so I've been in the intersection of transportation, building electrification, and consequently the power grid. And so I got very interested in this topic of aging workforce and how we can actually solve this. And so here I am with Adam putting together this panel. Thank you.
So, Aaron, yeah, tell us a little bit about yourself and what you're excited to chat about.
Thanks, Adam. It's a real honor. So my name is Erin Westberg, and I'm with NextEra Energy Resources under the umbrella of NextEra Energy. I've been in power and the water space for 25 plus years. And as you can imagine, we were talking in the previous session about the evolution of energy and as the intersection of water and power, it's really an honor to represent the workforce, but also a challenge to see how that's evolving. And I'm really excited to pick the team's brain and the panelists' brain, as well as the attendees, to see how we can solve some of our challenges here today.
Awesome, Don. Where are you calling in
Good
from?
morning. Good morning, and also thanks for the invite. Just so everybody knows, of course, Aaron and I will be thumb warring after this as, gentle rivals, being that I'm with Entergy, and I started out in the nuclear Navy, did a stint with specialty gases, but the last 15, 16 years or so, I've been in nuclear power. Definitely have seen the aging workforce in terms of both operations and the maintenance side of it. So interesting to see what other people are seeing and what they're doing, and share what we've seen on our turbine decks with how we're trying to, transition, save some of that knowledge from those craftsmen and transfer it to the young folks coming into the industry.
Anto.
Awesome. Thank you, Adam. Yeah, I'm Anto, CEO of Cosmic Brain AI. What I do is mostly train robots, humanoids to do different tasks, whether it be working in power grids or working in an Amazon warehouse or teaching robots on how to fight. So wide variety of stuff. Before this, I used to work at xAI, building Grok along with Elon and training the Optimus. And before that, at NASA, working on robotics as well. So a deep experience in robotics. But I did my electrical engineering, where I actually worked in a substation and a nuclear facility for my internship in my sophomore year of college. So yeah, that's the experience. Thank you.
Awesome. Well, we're going to jump right into it, starting with the state of the industry and really understanding what the big risks are with the broadening knowledge gap. So I want to ask everybody kind of what is really at risk here. And I want to start with Don. How is this showing up for you on, on the job, working on these turbines, and what are you finding to be the hardest to replace?
So on the maintenance side, you're seeing a much higher proportion of what we call new to nuclear. So not only are they new to nuclear, but, and this is the millwright craft, a lot of them are new to the millwright craft. So not only are they still learning the technical hands-on, literally as things that I find natural, the use of a torque wrench. The younger generation, and they're very digitally oriented, having hands-on tools is a new skill set for them. So, and then to pile on that all the constraints at a nuclear power plant, it's a much different animal from a fossil or a substation to going on to a nuclear plant. So they're just barraged with information and rules and regulations that they're having to deal with while we're expecting them to perform at a high technical level. So the key thing there is really just giving them the time to let all this stuff soak in while pairing them up with some more experienced workers to learn not only the nuclear culture, but those technical skills that are really vital to ensuring these turbines run the entire cycle.
Awesome. Hunya, I want to ask you a question about since kind of you coming with the more recent academic angle, why are we seeing this kind of this smaller pipeline of talent coming from undergrad, graduate students?
So this is this interesting conversation that I had with multiple people, like in my personal career. Like I was talking with people from Humboldt County, people from MV Energy, and they all report the same phenomenon, which is young folks are not enrolling in jobs that are, field engineers or technicians. So those technical expertise are more oriented towards going for like big tech and like this kind of roles where they can actually maybe earn more money, be in a metropolitan environment. And so the workforce that covers this specific role in power stations and or like transmission lines and things like that are disappearing basically. And so it's a problem. And as of now, it remains an issue. So they are trying to do to attract more talent, creating like educational programs and trying to incentivize the young community to enroll in this sort of jobs. But it's a problem. So yeah, something is changing, and I think the industry is trying to understand how we can actually solve it. So
Aaron, where do you see the highest risk as this lack of talent continues happening?
Well, there's kind of like inside the fence and outside the fence, right? So you want to attract the right talent. And I think that, the first two folks spoke well to what it takes. You have to get the folks to appreciate what we're trying to do and that we are a high tech, high paying industry on a lot of fronts that young people aren't necessarily seeing. And it starts in early childhood education and really showing them that these are excellent careers that pay six figures and that with certainty. So that's kind of outside the fence. And then inside the fence, it's cultivating that knowledge capture and knowledge sharing, and then evolving to kind of a smarter data share so that people even internal to your own company feel like they're challenged and retained, with intentionality to really be a really smart workforce, and they're empowered to do their jobs really well so that they feel that they're really, empowered with the right information and they're not working in silos. So I kind of answer it in twofold, right? It starts with just visibility to these are great careers externally, and then internally growing your workforce and giving them the tools to share those skills.
And going in a circle in the group, and this is also a good question for the audience to drop their answer to in the chat, is what is the biggest barrier at your organization? Is it pipeline of new talent, retention, documentation, tools, or culture? And just kind of a one word answer on the group, and then we can dig into the answers a little bit, starting with Aaron.
Our surveys tend to be around work processes.
Work processes, Don.
I'm going 2 words. It's pipeline and process.
Gotcha. Anto, what are you saying?
It's definitely building the complexity of the robots and training these robots.
The
Yeah,
process.
process.
Yeah.
Yeah, I would say maybe processes too. Yeah.
So where I want to kick this to Anto because he's working on the tech side of these robots. Where are you seeing these processes or the robots and the technology able to come in where those human processes that are missing maybe don't need to be brought up again by humans and technology can kind of take over?
Yeah, so we are actually seeing a big shift in the physical AI market, right? So, if you look into the history of technology, right, we have seen the internet revolution, we have seen the AI bubble coming up right now, and the next big phase is definitely going to be physical AI, and we are building robots that can actually replace or do the same task or assist humans in their workforces, whether it be in a nuclear field or whether it be in a substation or in a mining field, right? So teaching robots the exact same process into these humanoid robots to do the task seamlessly is very, very important, right? And right now we are collecting a ton of data on how humans interact with their real world, whether it be in a mom and pop store making pizza to whether it be in a mining field actually disposing of the dirty materials over there, right? So there's a huge element of training, fine tuning, even like guardrails. So as humans, we work in these environments. There's a ton of safety measures that we have to take in place, like when dealing with hazardous materials or dealing with different objects in a very big substation or these kind of stuff. So our main goal is to transfer those safety requirements into these humanoid robots so that they don't actually cause way more danger than the humans are exposed to as of today. And in hand, in the next few years, decrease the safety hazards for humans in construction environments, these kind of environments to kind of like replace it with the humanoids so that they're much safer and much more reliable and can work autonomously for a long hours of in their shifts and stuff. Yeah.
So shifting direction a bit here, let's talk about the supply of the talent. So who is going to become the experts of tomorrow? And Don, I'll start with you. Industries, I think, kind of have to invest a lot more in the trade and vocational schools, the same way that I think my generation, millennials, was told you have to go to a 4-year college. What is working or maybe not working in orgs like Entergy to push more people into the trades?
Well, and I'm going to take a step back because you hit on something that when I say pipeline and you're asking why people aren't jumping in this, we've had 50 years, give or take, of college, and not college in STEM, but it was accounting, CPA, business, maybe in the liberal arts. And quite honestly, hands-on labor was denigrated. Let's face it, I've been in rooms where you got all the managers and they talk about the craft and the trades as a disposable commodity rather than the actual partner in excellence that we need them to be. So what I'm saying is, we have presences on college campuses, we get college interns in, and I think what we need to do is apply that same effort towards the vocational trades until robots are able to do a lot of stuff. And we know robots and AI aren't ideally will never replace humans. Otherwise, we're going to be in a Wall-E type situation. Where we're just, brains in a vat type deal. We need to show as an industry that we actually respect and acknowledge that craft tradesmanship that's out there. And like I said, when I get them on my turbine deck, give them that time. We're always schedule. But guess what? Taking 10 minutes, 20 minutes out to make sure these people understand how to put this machine back together is going to give me long-term value of a turbine that can run through the cycle. Does me no good to short my schedule by a day, say I saved $1 million, and then turn around 6 months later and have a forced outage that's going to cost me 50 million. And we've got a very short-term financial thought process reward situation that's just not helping us.
Aaron, I see a lot of head nodding over there.
Yeah, I'm just, quality is critical, and in any practice, that whether that's data engineering or, a physical practice or a construction role, quality is crucial to everything that we're doing in this role. And a lot of this is new, right? We're discovering new failure mechanisms for solar and batteries, and the robots are doing new things, and we're developing new materials. And so I think that we as thought leaders have to really be intentional about quality. But to answer your question more directly, the pipeline, if you think about, okay, I'm going to use a P word, like politics is local first, in the sense that you have to think, what can I do for my block? What can I do for my town? What can I do in my neighborhood? Like, who needs a job in my neighborhood? I live in South Florida. So, we don't have a lot of manufacturing per se, but we have solar growth, and we have transportation growth, and, we have, a certain type of industry. And so we have to cater to, who lives here, but also who wants to move here, and think intentionally about that pipeline. And there are young people, and they want to work hard. And there are a lot of people who want to work with their hands, and they think that college is somewhat out of their reach. And so kind of providing that bridge for everyone really is enabled vocational programs, like I mentioned before, in water and in energy. Those, each local utility across the country is thinking about that, whether that's water or energy. And then if you apply that to high tech or construction, each of those programs, and even when you talk about some of the apprenticeship and prevailing wage requirements of the IRA, like those apprenticeship requirements still apply. So those programs do exist, but we as business owners or practitioners should lean into those programs. And who are those business owners in our community that are leaning into those programs, and who are the pipelines? And then throw a golf tournament, or do things that really highlight our partnerships as owners in that process, and buy our own PR, if you will, and get kids involved with young people, middle school, and high school, for volunteer hours, to do things. And then they realize, oh, I didn't realize you could work for FPL, and you didn't have to be an electrician. I didn't know that. And just kind of start having those conversations across the whole swath of the community. And then no matter your skill set or your interests, you'll find a niche, but you have to have the whole community sort of involved in those conversations.
I think that's a really interesting angle there, and I want to move into kind of the opposite direction and ask Anto. So Anto, you started in energy, right? Your first business was energy and water, and then you exited and you went into space. What kept you, I guess, pushing away from energy? What made you go away from energy, and what's bringing you back into it?
Yeah, I think so I did my first internship in this Russian nuclear power plant, which is like I got a ton of insights there, right? So how a nuclear facility is actually getting run, seeing the complexities in a substation, and even as an electrical engineer, you deal with like heavy equipments, right? Which is a space which is super difficult. There's like all these like big corporations controlling in that field, right? So as an energy company, as a startup, it's very difficult to enter a space that's already crowded by these big sharks. That's one main reason that I kind of like did not go back to energy. Second thing, the company that I created was mostly of like clean tech, and we were like saving ton of energy by using solar panels to, recycle water and make pure drinking water, and we had the smart tech and all these kind of stuff, right? That was again like I sold that company. I built that company out of my dorm room in my undergrad, sold that company in senior year of college. So that was a good experience. I almost got kicked out of my dorm room for doing that because it got the power of the entire building got shut down. It was a good experience. But yeah, then I was like, okay, what is the next big thing that I'm actually interested in? So there's a lot of physics And there's a lot of ultramagnetism and everything in space technologies, right? And robotics is the next way forward. And there's a lot of things that you can actually accelerate in the energy field with robotics. And that's one of the reasons I decided to start working at NASA. And I was like, oh, this is great, like all the space mission. How can we create the energy for the future, creating solar panels in space? And if you're actually sending a rover to Mars or to Moon, how can we create small energy modules there? So these are all the stuff that NASA is currently working on, right? So the problem becomes way more different, like way more modular, right? I think the energy of the future is definitely a modular source of decentralized energy system where people can have like nuclear fusion or like anything. That there is a ton of startups working on it right now. So yeah, I believe in that vision. Even at XAI, we were powering the largest superclusters in the world, 100,000 GPU clusters with Tesla Megapacks, right? So in order to power like a million GPU clusters, you need the power of 10 nuclear power plants. That's a lot of power. And the biggest crisis that humanity is facing right now is how can we quench the thirst of power for AI systems, right? Data centers consume a lot of power, but like more than what humans have consumed so far in the history of humanity, right? Which is a crucial problem right now. So we need to find renewable energy. We need to find other sources of energy, which is modular, which is easily deployable and easily solves the data center issue, right? And there's another thing with cooling and all these kind of stuff. So people are working on data centers in space, and people are working on underwater data centers. There's a ton of different varieties of stuff coming out in the market as of today. And yeah, I'm super excited to work in this field, especially in robotics and data centers, AI and stuff. And yeah, I'm very bullish. Someone has to solve the energy problem now or sooner, or else there's no way forward. We'll be doomed as a civilization if someone does not create innovative solution for energy.
Yeah, so we can't be waiting, right? So we can't wait
Yeah.
certainly 10 years for, newer generations start learning. And, question for the group that I'll actually start off with, which is how do we compress kind of these learning curves in your mind?
Well, that's a very big topic. I would say that, connecting with what Aaron was mentioning earlier about creating programs. So I see it. I see it as in two ways. Like I think there is one flow that is trying to incentivize the young folks to join professions that can support this workforce that is disappearing. And so from electricians, people that like to work with their hands, power plants type of work, transmission lines, field technicians and things like that. And on the other side, I think we have this amazing possibility technology that is, supported by AI and robotics. So I think there are certain roles that perhaps can be complemented by this technology. So perhaps there are certain professions when there is a power outage, uh, technicians they literally have to climb on a power line, power pole to fix physically the wires, and those are also dangerous technology. Or like even like moving other industry like mining, like materials that are toxic, air quality and problems like that. So those can be taken over by maybe robotics, and so prevent humans to expose themselves to roles that can be dangerous. So I think there are two flows. One is preserving a type of workforce for those who want to join, and then at the same time using this technology that can complement the future of the workforce in the specific like power industry or other heavy industry fields. So, yeah.
Aaron, before this call, you mentioned to me something called communities of practice, and that's something that you all are implementing in, or in your workflows. Talk to me a little bit about that.
Yeah, so I liked what Hunia said about like risk mitigation, and I think the communities of practice is somewhat of the next phase. So any practitioner in any area across the country, across the world, that's, let's say, working on a certain software or a certain application or a certain technology, has a certain question. So real time can ask a question of the subject matter experts across that community of practice and get a real-time answer. And I think it's kind of born out of that Craigslist feel, of the 90s. But now what you have, now you have a human in the loop. You have all the AI answers, but what you don't have is like your company specific policies and protocols. But if you can merge those two, now I understand, the context from AI, but that doesn't necessarily give me the very correct answer. Now what I can do, again, inside the fence, I can validate with the right procedures and the right protocols with, with other humans that have done this very specific job before. Don was mentioning there's new to nuclear folks. Imagine if you had at your fingertips all the folks who've worked at that site before, or all the folks that are in Entergy, and you could ask them quickly a question. You could utilize AI to get all your policies and procedures, and you could get 95% of the way there. And then the people could, verify, triple check and verify that, yes, that is the right policy. It's applied in this way. Then you could use, let's say, augmented reality, and, someone could talk you through it. Like, these are like a triple layer of ability that now this new worker is not out on their own, but they're upskilled in a really special way that we didn't have before. It was like, hey, you got to be here 87 years, kiddo. Learn the hard way, risk life and limb. And now we're mitigating the risk, and we have the ability to use, machine learning and, augmented reality, and provide things at the fingertips of the folks that are doing the work, whether that's physical work or digital work, right? I mean, turn me into a vibe coder, and that's a little scary, but I think it's really exciting. And then I can validate, hey, is this really the right code and result with someone, more skilled in that? So it's exciting to have kind of that ecosystem to, to explore in, because some of us are still learning, right? Some of us haven't been to the moon, so we're trying to get there.
I want to pull on that thread about taking these knowledge bases, using the tools to access them faster, and ask kind of Don, how are you all right now managing that knowledge through your kind of like post outage workflows, after action reviews, playbooks, those kind of tactics?
And we're not doing it well, even though it's in our process. And I'm going to back up because Aaron hit on something specific. So it's not necessarily as well as who we're training, but how we're training them, right? So we'll capture our lessons learned. We'll nod at a post outage critique, and then we're already thinking about the next outage. But if you go back prior to that, we're still in the PowerPoint era. And coming from my instructor side and training side, too many people look at a PowerPoint. You got all these generations now from the digital era that have this concept that I can read something and I know everything about it. And we constantly have taken out the human interaction in learning and training. There's a difference between training and learning. I learn more when I have to teach somebody something that I thought I knew about. And then you uncover all the holes in your own knowledge. And you cannot teach somebody how to take a depth micrometer reading off of YouTube. It's great. It'll start it, or off the PowerPoint. You still need that human interaction. So like Aaron was saying, we have this opportunity to layer baseline knowledge that you can get from the PowerPoint, from the AI. You've got to make it interactive, right? 3D modeling, digital, you can do animations to show how a machine comes apart, goes back together. And then eventually you've got to marry that up with somebody that has a hands-on experience and get them in the field. Adults need to be moving to learn. Okay. I have all the CBTs that I have to do at Energy every year, and I just click through. I couldn't tell you what's on half the slides because I don't read them. right? That's just being honest with the way I know I learn. So we have to understand who we're training, right? Get that in pipeline. The naval nuclear power group has gone down. That's why we're not getting those operators in. If you get a college student that has a mechanical engineering degree but never did any hands-on field, that doesn't necessarily make them have the mental model for an operator. So we have to understand those differences. AI has a lot of capability, garbage in, garbage out, right? You got to make sure, to what Aaron was saying, it's got to be specific to your needs, because if it just goes out into the world and grabs everything, again, it's going to think that I can do fusion in 2 years, right? That's an impossibility. It's not going to happen. So we've got to make sure it's specific, interactive, and we still include that human element to get that in. I don't think that answered your question, but when Aaron was talking about the merging of the two, I'm sorry, I'm a little passionate about that.
Yeah, no, I think that's a really good point, and actually use that to kind of talk a little bit about the technology gap in this, right? Because technology is supposed to make that what you're talking about easier, right? I don't think it does properly a lot of the time, especially, in, the areas that I'm in here, Silicon Valley, we got a lot of people saying how great technology is, but then you talk about how do you actually implement it at a utility, talking about the 65-year-old maintenance manager, like actually going and doing the work on the technology to make it work. It's kind of hard sometimes. I actually want to ask Anto about the tech stack that they're using to take in all of the information that the robots are then being trained on.
Yeah.
Yeah, physical AI requires like a ton of different tech stack, right? And I see this as the evolution of like what we have done so far in the tech world. Like from right now you have cursor for robotics, that you don't need to like do hard coding or PyTorch fine tuning and anything to actually build an app or website, right? So technology has become so easy, so even a non-technical person can actually build apps and websites with cursor, right? For robotics, we are going with a similar approach right now. So I'm actually building the cursor for robotics that allows anyone to upload human data and transfer them into skills, right? And this behind the scenes, it's evolved with a ton of different tools like foundation models, synthetic data, simulations, physics engines, to like synthesis of data in itself. Like there's a ton of different things that we have to plug in behind the scenes, right? So some of the mechanisms, like how like a humanoid is getting trained, is first, it's just like if you're a mother, you can understand this better. It's just like training an infant on how to like stand up and walk and run and deal with different objects, right? So it's same like that, training a humanoid. The first thing that you got to do is like teach a humanoid on how to balance itself, how to get up from the ground, right? So for that, you need to understand the physics of the real world, what motors in your legs should actually have apply the certain kind of force for the robot to actually stand up on the ground. Next thing is walking. So a robot that can understand, have the perception of the real world around it. So far AI LLMs are very textual based, like LLMs are large language models, right? So right now we are getting into the phase of physical AI, where we are getting putting AI into a human form, into a physical form that can actually understand the world similar to humans, right? So for that, the first thing that we have is the skin and the sensory outputs, like vision to see and the ears to hear and mouth to speak and nose to smell, right? How can we actually replicate this in the humanoid form, like sensory input? So we have a ton of different sensors, including LiDAR and IR and these kind of stuff for the robots to understand depth, where to go, where not to go, what is a glass object versus a solid object, marshmallow versus a candy, these kind of stuff, right? And the second thing is data, right? So in order to train a humanoid like a baby or like a actual human infant, yeah, it will probably take 14 years. And we don't want to wait 14 years to train these humanoids. That's something that actually Waymo did. So Waymo took almost 14 years to train its cars in the streets of San Francisco before it actually launched, right? So that's one of the reasons being that Waymo had to be aware of different scenarios, how to stop at a traffic light, how to navigate through the roads, how to avoid pedestrians, and drive for 14 years is a huge time. So the way humanoids is getting evolved right now with AI and data, we can capture data or skills from millions of people across the world and actually input that into a humanoid in Silicon Valley, right? So you don't actually need to take this humanoid everywhere that you go. So these are some of the accelerating factors that's actually inputting a ton of skills into a hardware that has not even seen the world in real life. So, and this is accelerating the mode of like training and physical AI much, much faster. Another thing is hardware in itself, right? China, there's a constant battle between China and US right now with who is going to win the physical AI market, because robots are going to be super important for manufacturing in the US, for building the GDP in our country, and robots are the future of US, right? So because we want to automate almost 90% of the industries out here. We want to build hardware in America. We want to build cars and energy plants and everything. And US has a huge labor shortage. And the only way to replace that is with automation. We need large industrial robot arms or humanoids walking around, or any form factor walking around solving these problems, right? And when you look at the industry today, China is developing super cheap hardware. Like this week I saw like a $300 a robot arm that can do anything for you, right? So it went from hundreds of thousands of dollars from Boston Dynamics creating robot dogs and humanoids to a very affordable robot, a robot that's under $10,000 in a human form that can walk around from China, right? Now you can use these robots to train skills. So it depends on where we are positioned globally in the manufacturing sector and in the AI market, in how we utilize this evolving the biggest economy there is. So when at X, Elon used to say this, like yeah, the physical AI market is the biggest the world has ever seen. It's like a $25 trillion plus economy, right? So how can we actually position ourselves to tackle this world, right? How can we educate ourselves to get into this new era of robotics and AI? So these are the stuff that I'm definitely working with, and there's a huge tech stack, huge skills that is needed as well. I encourage more developers to start building and start looking into robotics and building in foundation models and AI models and stuff to actually enhance the pathway forward. So yeah.
Continuing into that physical part of this, Aaron, NextEra uses all sorts of drones and advanced monitoring. How are you using this data to train your teams, whether it's from drones analyzing solar or wind farms or whatever you guys are using right now?
Yeah, I mean, it's you name it. Like, I don't even know what I don't know for the full scope of all of the projects, from risk mitigation, wildfire risk, comes to mind for you in California in particular. But, we're looking at scanning and, remote monitoring. These things don't have a lot of people like you imagine, the workforce of the past. So you have to use, sensors and intelligent, validated alarming for a lot of these, advanced monitoring. And so that comes into play. And then again, validated data. So we do have drones for inspections for hard to reach areas, even internal to like a boiler space, where previously you had to have, a human enter that space. Now, I mean, our nuclear fleet and our, fossil fleet, I mean, in the whole country, like you can enter spaces and achieve inspections without a human, in that space robotically. And that really, I mean, not to mention now you have the ability to have a sensor in there, collect specimens, et cetera. And that's, just what I call a plain robot, right? That's without the use of AI on top of that, collecting that data and then learning from that data and looking for patterns. So I'll also put a plug out. We have an incubator called 35 Mules, and that is always looking for startups, not just in the energy space, but for innovation and in data. And we're always looking for, the companies that are doing innovative things. And some of the technologies that, we just mentioned are included, right? They're looking at smarter transmission lines and smarter substation controls and wildfire, not just notifications of wildfires, but like, what is the BTU of this slow growing or fast growing plant, and how do I build a vegetation management program around it, right? There's so many different tools out there that I think you have a sensor, but now because and you're more comfortable with just more data, now you can dive deeper into managing that data and looking deeper into it. And then you put that into an ecosystem and a regional or a national kind of database. And like Anto was saying, you now you're training it on multiple data sets, and you can find things that you weren't even looking for. So I think it's really exciting whether you're talking about, mechanical inspections or thermal inspections, or, just the 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 retroactive review of engineering data. Right now, I can instantaneously go and look at historical data, whereas before I had to be, I had to hunt and peck for those trends. But now I can use AI to, write Python code and go and look back at my historicals and look for those trends. Look for that needle in a haystack with my AI assistant, as opposed to just myself, right? Because I'm still a skilled investigator, so I know what I'm looking for, but I can use my AI assistant for that. So those are just a handful of things that I think are really exciting. Not to mention like like robotic mowing and all the other things. And so you put sensors on the mowers, and now that can do many things. Although sheep are still pretty cool, right? Let's agree that sheep are still pretty cool, but
Sheep are definitely cool. Before we switch gears into kind of some, action items that can be taken away from some of this info, Junio, where do you see kind of the biggest risks or areas to watch out for when we're implementing this new technology?
So, so something that I was thinking is the individual professional. So as we mentioned before, is perhaps a field engineer that works in a power station for like 20 years. So he knows the power station like in and out perfectly. And one of the and then this person, it's going to be retired soon. So how do we recover this subtle type of knowledge that is based on purely on experience, and so how do we recover that knowledge? And if we wanted to use some sort of technology, it has to be a technology that stays with this person for a certain amount of time, and then so we can pick up like that information based on sensors of some kind. So, for example, I was chatting with Anta, and I was very fascinated about using, for example, glasses, like smart glasses that can recover whatever activity this expert is doing in his day-to-day job. And I think it's a very fascinating point where we really have the convergence of like this crazy technology, and then asking an individual that maybe is like at the end of his career, that spent in this same work environment for like decades, to wear like an external body under eyes, and then like collect all this information. So I see it as like, and it's very important. It's important to recover that knowledge. But I think it's a great, interesting topic that is putting together like technology and knowledge, and the value of this knowledge in the future of like managing these power plants, and ethics, and like, are these people like open to do this sort of thing? So like, or maybe yes, maybe they're actually interested, or like maybe some are interested and some are not interested. So yeah, so this, I think it's a very fascinating topic that it's not very talked, but yeah, so.
Great. No, I think that's a really great insight. So last thing here is kind of a quick 2 to 3 sentence. What is a takeaway that you want the audience to take from what we're saying here, and something that they can actually do, the next weeks, months, year to implement new systems? And while I do that, I want to invite the audience to put in any Q&A into the chat, and we can do Q&A before we move into the networking session. And I'll just bounce it back to you who need to go first.
I think is really putting together young folks, professionals, and technology, and making technology part of our society as much as possible. So it's like become like the new normal. Like robotic is the new normal. Having a pair of smart glasses is the new normal. Collecting information for given privacy and everything, it's the new normal. Yeah. So this it's I think what the future is going to be.
Awesome. Aaron, you next.
I know we touched on it, but every single person is a data engineer in their profession. I mean, even if you're turning a wrench, you still need to understand the data ecosystem. So with that said, I mean, to piggyback on that, right? Like you're never too young to learn how data is impacting your life. And I think, think about who in your life you can impact. And middle school, like grade school, like, people are hungry to be relevant. And like we are some of the most relevant people on the planet. So like how can you spread that message of relevance and excitement to your community and volunteer some hours to some STEM camps or something. I think you'll get a lot out of it. And then how do you internalize that to your own work group? How do you like what is the singular problem that I want to solve, and take matters into your own hands and build a dashboard so you don't ever have to recreate that trend again, right? For example. So it's kind of super, super global. Everybody's a data engineer, then it's in your community, and then it's in your work group.
Anto, 2 to 3 sentences on what you think is a great takeaway from this conversation, what our folks in the audience can do next.
Yeah, absolutely. So I believe that physical AI and energy are going to be the next crucial verticals to definitely put your focus on, right? So if you're not working on that, so AI is going to replace a ton of jobs. Like almost 60% of the coding in Microsoft is done by AI agents, right? And eventually almost every job that the software engineer does will be taken over by AI. And the only market that you can go to will be energy, blue collar jobs, or physical AI. And right now is the best time to actually focus on that, start building on it, start educating yourself on it, get courses on it, and yeah, be out there. So that's my advice.
Don, what do you got? Last words.
I think the key thing is to embrace the technology as a tool and get out of this digital realm where we've seen technology, and I'm going to throw social media in here, has actually started isolating people and removed the human element. Use the technology, this digital AI, this physical AI, right? How do we digitize a memory that has form, function, thought, feel? Because just because you see something, it's a video, do you understand the thought process? What caused that person to look at something, right? The sound of the machine, the smell. And start bringing the technology back into a human interaction so that we're using technology to actually increase the human interaction and learning, because that's where you really have your strength when you have more people looking at something from different perspectives with that AI and technological background to really make better decisions and better quality products.
Awesome. Thank you so much. So we're actually going to move into the networking session now. There will be two groups. I really want to thank our panel for coming. We put their LinkedIn information to follow them and connect with them further on these topics. I also just dropped in some information about our biweekly coffee chats, which are just now working, chatting with other folks. I also want to invite everybody to come to the Grid Investment Summit or to go to the website and learn a little bit more about it. We just launched this the other day. It's in April. It's all about exploring how capital is flowing through the grid, supporting these technologies, supporting new green projects all around the world. So I will be opening these two networking groups here, and you can just go ahead in the breakout rooms section below and click which ones. It's going to be Aaron and Donald to chat about utilities and Hunya and Otto to talk about tech.